Okay, apparently videos can't last that long, so this is part 2 of the video. I'm working on the second FRQ. I hope this all works out. Okay, so we've got this table here full of data points, and they want to know the equation of the tangent line at -1 for h of x. Okay, so y equals mx minus 1 plus, x minus minus 1 plus y1. Okay, so to get the y value, I just plug in -1. So I do 2 times f of -1 over g of -1. And f of -1 is 3. G of -1 is 1. So my answer is 6 for my y value. All right, and then for the slope, I just need to find the derivative at that point. So the derivative of h is a quotient rule problem. So I've got low d high minus high d low over low low. And I'm evaluating this at -1, so I'm just going to plug in all these values. So g of -1 is 1. F prime of -1 is -2 minus 2 times, because there's already a 2 there. F of -1 is 3. G prime of -1 is 1. All over g of -1 squared. So I get -4 minus 6 over 1, -10. So I just plug that in for the y value. So y equals, for the slope, this. Cool. All right, for the next one, they want to know the value of this function at 0. So, or not the value, the derivative. So to take the derivative, it is a quotient rule problem. So I got low d high. Okay, so the derivative of 3x is 3, and the derivative of cosine is negative sign. Okay, minus high x d low. All over f of x squared. So I can write it in a second set of parentheses squared, or I can just write it there. Okay. And I want to evaluate this at 0. So f of 0 times 3 minus sine of 0 minus 3 times 0 plus cosine of 0 times f prime of 0 all over f of 0 squared. All right, f of 0 is -1. Cosine of 0 is 0. Oh, that's a minus. Okay, 3 times 0 is 0. Cosine of 0 is 1. And f prime of 0 is 2. All over f of 0, which we already said was -1, squared. So I get -3 minus 2 over 1, which is -5. All right, and now we've got one more, and we want the slope of a normal line. Remember, normal means perpendicular. Quotient rule again. K prime is low d high minus high d low. Okay, the derivative of 3 is 0, but there's still that negative out there. All over the bottom squared. Okay. And I want that at -2. So 3g of -2 for f prime of -2 minus 4 times -2 plus f of negative 2 times g, negative g prime of negative 2. Oof. Over 3 minus g of negative 2 squared. So I do 3 minus g of negative 2 is 2. F prime of negative 2 is negative 1. Okay. Then we have 4 times negative 2 is just negative 8 minus, no, plus f of negative 2, which is 1. Negative g prime of negative 2 is 4. All over 3 minus g of negative 2 squared. These are all becoming 1 on the bottom. That's nice. So I got 1 times 3 minus negative 7 times negative 4 over 1. So that's 3 plus 28, which is 31. Cool. All right. One last FRQ. All right. This is another one about differentiability. Okay. So we got a piecewise function, and they're saying A is negative 3 and B is 4. Okay. They want to know, will it be continuous at 2? Well, we're broken up at 2. So basically we want to know if the limit from the left is the same as the limit from the right. And our value of A is 2. Okay. So we're just going to plug in 2. A is negative 3. So I get negative 3 times 2 squared. They said B is 4 times 2 plus 2. And I want to know if that's equal to A is negative 3, X is 2, B is 4. Okay. So that's negative 12 plus 8 plus 2 and 6 plus 4. So I get negative 4 plus 2 is negative 2 equals negative 2. Yes, that's true. Therefore, f of x is continuous at x equals 2. Okay. Now, the second question is, will it be differentiable? And we talked about differentiable a little bit. Okay, differentiable is the exact same thing, except for the limit from the left and the right are not referring to the function, but the derivative of the function. Okay, if the slopes match. So, if A is 3, okay, the derivative of the left side is negative 6x plus 4. And the derivative from the right is just negative 3. Right, because it would be negative 3x plus 4, and the derivative of that is negative 3. Okay. And then I'm going to plug in 2 to see if it's the same from each side. Okay. So this is negative 12 plus 4, which is 8. Since those are not equal, therefore not continuous. No, sorry, not differentiable. So it's continuous but not